Okay, so hi, this is Mrs. Often, and I'm here to talk to you about solving quadratic equations. We're going to review 3 ways to solve quadratic equations today. The first is factoring. The second is completing the square, which you should have studied in Algebra 3, and the quadratic formula, which I'm sure you all know and love. So our first example is to factor and solve. Always, the first step in factoring is to look for that greatest common factor, the GCF. Here, the greatest common factor is 3. I'm going to factor that out, dividing each term by 3. Now I have something that's much easier for me to factor. You may want to check by multiplying your 2 binomials together to see that x minus 4 times the quantity x minus 2 does in fact equal x squared minus 6x plus 8. So now I can write 3 shorter equations. First one, 3 equals 0. Okay, I know that's never true. The second, x minus 4 equals 0, gives me a solution when x equals 4. And the third one, x minus 2 equals 0, gives me a solution when x equals 2. So the 2 solutions to this quadratic equation are x equals 4 or x equals 2. Our next example asks us to factor and solve, and here a, our leading coefficient, is not equal to 1. So I use the technique of a times c has to add up to b. So I'm going to think of 2 numbers that multiply to make 60, because 5 times 12 is 60, and that add to equal 19. So the first pair I think of is, I'll just check 5 times 12. 5 times 12, that's 60. But 5 plus 12 is 17. That doesn't work. So I think of another pair. How about 4 times 15? 4 times 15 is 60, and 4 plus 15 is 19. This means that I'm going to rewrite So I've split that term 19x into 2 terms, 15x and 4x. Now I'll factor by grouping, dividing out my greatest common factor, 5x. That gives me 5x times the quantity x plus 3. Dividing out my greatest common factor of the second 2, I have 4 times the quantity x plus 3. I know I'm doing a good job if I have 2 sets of parentheses that match. My first set of parentheses is going to become the 2 things that were outside the parentheses. So 5x plus 4, that makes my first set of parentheses. My second set of parentheses is going to be this, x plus 3. And again, it's worthwhile for you to check using multiplication to make sure you get back to this original polynomial. Once you feel confident about that, and feel free to pause and check and make sure that I'm doing this right, then you can write your 2 equations. 5x plus 4 equals 0, and x plus 3 equals 0. The first one x equals negative 4/5 is my solution, and my second solution is x equals negative 3. So there's my two answers to this quadratic equation, 5x squared plus 19x plus 12. One solution is x equals negative 4/5, and one solution is x equals negative 3. So those are two examples of factoring to solve. Our next example is going to be completing the square. You probably use this in Algebra 3. We're going to be using it again this year, especially in our study of conic sections. However, full disclosure, I avoid using completing the square whenever possible. Our goal in completing the square, as I've written here, x plus h, quantity squared, equals b squared. So I need to turn the expression that's on the left-hand side of the equals sign into a perfect square trinomial. I do this by first moving over that constant term. So I'm going to rewrite x squared plus 6x equals positive 4. I've added 4 to both sides. In my next step, I need to complete the square in x right here. I do this by dividing 6 in half. 6 divided by 2 is 3, and squaring the number that I get. 3 squared equals 9. I'll add that 9 here, and remember, you need to add 9 on both sides so this equation is still true. Now I have x squared plus 6x plus 9. Well, this is a perfect square trinomial. I can factor this to x plus 3 quantity squared. 4 plus 9 is equal to 13. So now I've achieved my goal. X plus h squared equals b squared. I can hear what everyone is saying. 13 isn't a perfect square. That doesn't matter. We're still going to take the square root of 13. We're just going to get an irrational number. You'll reduce the radical if you can. So I'll have two equations. X plus 3 could equal the positive square root of 13. Or x plus 3 could equal the negative square root of 13. Now this is the step that many people forget. I don't really care what x plus 3 is equal to because we're solving for x. So please don't forget that last step of subtracting 3 on both sides. This is going to give me my final answer. X equals negative 3 plus the square root of 13. Again, or x equals negative 3 minus the square root of 13. So you see I get two different answers here from completing the square. And generally I am going to get two answers from completing the square unless the sum on the right-hand side ended up as 0. And then I'll just get one answer from completing the square. But usually I get two. Another useful thing to remember is that if you do have a perfect square, then you should add those numbers together. No math teacher wants to get an answer like x equals negative 3 plus 4 and x equals negative 3 minus 4. We know if you've made it this far, you can add. So don't forget to do that. Well, if you don't like completing the square and you can't factor something, you can go to something that works every time. And that is the quadratic formula. This is guaranteed to solve everything. If you can factor it, you can solve it with the quadratic formula. If you can solve it with completing the square, you can solve it with the quadratic formula. If it has imaginary roots, you can solve it with the quadratic formula. So here's the definition. If we are given this form, ax squared plus bx plus c equals 0, the quadratic formula tells us that x is equal to the opposite of b plus or minus our big square root b squared minus 4ac all over 2a. This is really two answers squished into a single answer. That plus or minus means that we can take negative b, add what's under the square root sign, or we can take negative b and subtract what's under the square root sign. So this isn't just one answer for x, it's two. All right, so we're going to solve this with the quadratic formula. Now you'll notice I've given my first equation, 2x squared minus 6x equals 7. And I've noticed this is in the wrong format. Don't identify A, B, and C until you've changed this to the correct format where everything is equal to 0. Once I've done that, I can identify A is 2, B is negative 6, and C is negative 7. So we're going to go ahead and use the quadratic formula to solve this. Write down x is equal to the opposite of negative 6 plus or minus the square root of negative 6 squared minus 4 times 2 times negative 7 all over 2 times 2. So I have x equals 6, the opposite of negative 6 is 6, plus or minus 36 minus, oh, that's going to be positive, plus 56, all over 4. So 36 plus 56 is 92. And I have 6 plus or minus the square root of 92 all over 4. 92 is not a perfect square. Generally, I'm going to write this as a condensed answer. I can reduce this radical. 4 divides into 92 23 times, so this is 2 radical 23. And I'll reduce my expression dividing 6, 2, and 4 all by 2 to get my final answer, x equals 3 plus or minus the square root of 23 all over 2. This is two answers, 3 plus the square root of 23 and 3 minus the square root of 23 divided by 2. So two different answers there, and you can evaluate those with a calculator to get a decimal value if that's going to be more useful in your application. Okay. So my final slide is when should I use each method? Of course, you want to know, when should I use each method? Well, obviously, if the test or the quiz or the homework says factor and solve, you have to factor. But in general, I use factoring if the quadratic is easy to factor. If I can factor that in just a couple tries, I factor it. Completing the square, I only use if I have to. If you really like it, you can use it all the time. And there are some special applications, like finding the vertex of a parabola, where we're going to have to use completing the square. And the quadratic formula, I say use it when all else fails. The quadratic formula is like taking out a chainsaw. If you have something that's easy to factor, are you going to use a chainsaw to cut butter? I don't think so. So use the quadratic formula when everything else has failed. You can't factor. You don't maybe remember how to use completing the square, then you can go to the quadratic formula. So that's it. Thanks so much.